Hello, let's continue our Sudoku adventure with quads by Strosahl. So we have normal 6x6 Sudoku rules, which means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. The only other thing we have is the only thing telling us where digits go are these quads. So it's these circles that kind of touch each circle touches 4 cells. That's why they're called quads. And in the circle are some number of digits. Each of those digits must appear at least once each within the 4 cells that the quad touches. So we need a 2, 3, and 4 somewhere in here. We could go 2, 3, 4. We could go 2, 3, 4. Go 2, 3, 4. Like, it doesn't matter how, but we need at least one of each of 2, 3, 4. The last digit can be whatever it wants to be. If a digit appears more than once, like this 1, 1, 2, that means the digit must appear at least as many times as it appears in the circle. So we could do like 1, 1, 2, for example. What we can't do is this, because even though 1 appears once, the second one appears nowhere. So this is telling us we need 2 ones at least. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, we have a lot of these double digit ones, which use up that digit for the entire column and row, right? So the only way we're putting 2 ones in here is to put them in 2 different rows and 2 different columns. So they're diagonal like that or they're diagonal like that. And that's going to use up the ones from all of these cells. So stuff like that can be very helpful. So for example, we know none of these are 1, right? Which means these 2 aren't 1. And that tells us the 1 for this quad has to be up here somewhere. That points in here. Yeah, we know one of these 2 is a 1 already. So one of these 2 is a 1, one of these 2 is a 1. That's kind of what we learned. Same thing with the 5, same thing with the 2. So the 2 here tells us that the 2 is on one of these 2. The 4 tells us 4 is up here. The 5 tells us these aren't 5, but the 5 could be here. What else do we have going on for us? Good question. I'm interested in, so kind of a counting argument here, although we have to be a little careful. There could be a 2 here, and that would give us the 2 for both of these quads. But in total, the quads want 1, 2, 3, 4, 5 2s. So that's going to use up 4 or 5 of our 2s. Yeah, I don't think that's helpful. Okay, there's a 1 and a 6 in this quad, and there's a 1 and a 6 in this quad. That's going to use up our 1s and 6s for these 2 columns, right? There's only 2 1s and 2 6s completely available at all for these columns. One of them's going to go up here, and one of them's going to go down here, meaning that there's no room for 1s and 6s here, right? If I try to put a 1 here, then I end up with a 1 here and a 1 here, or nowhere in this quad, right? Etc. And so this actually ends up being a 1-6 pair because we got to fit the 1 and 6 somewhere in this box, and they can't go here. Or if you prefer, they need to go somewhere in this column, and they can't go here and can't go here because they're over here and over here. That 1-6 pair actually disrupts both of these quads quite a bit. So we need 4, 4, and 5 here. We're not doing 4, 4 like this. So we're doing 4, 4 like this, and then we have to fit the 5 in. And that makes this a 1, 2, 6. The 1 goes here, the 2 goes here, and the 6 goes anywhere. And that leaves the 3 behind. And so down here, this is going to be the 2, 2. This is going to be the 3. And that finishes this column with not a 1, with a 5. This column finishes with whatever the other 1, 6 is. These 2 cells are a 3, 5. But this 5, 5 looks in, telling us that's not 5. So that's 3 and that's 5. In fact, I can just corner mark 5s like that. Well, we know this isn't a 5. Oh, right. This 5, 5 has been resolved from the start. We can't do 5, 5 like this because now there's nowhere for a 5 in this quad. So we have to do 5, 5 like that. That fulfills the quad. That does mean there's a 5 up here. In fact, this 5 looks in, these 2 5s look out. It places the 5. That places our 4. And now this can't be a 1 because we need to fit a 2 and a 3 in here. So there's no room for the 1. So that's our 1, that's our 1. And then this could be a 2. Anyway, that's 6 and 1. All right, this is a 6. All right, this quad needs a 6. This 6 says it has to go here. That actually resolves our 1, 2, 6 here, or 6 down here. This is a 1 and 4. All right, over here we need a 2, 3 pair. So this is a 2, 3 pair here. This digit's a 4 just for the box. And so this is a 1, 6. That's our 1, that's our 6, gives us 4 and 1. We are going to need a 3 in this quad. That can only go there now, giving us 2, 3, 2, 3. And then down here we need 2 and 4. And we're done. Cool. Nice quad puzzle, Strosahl. You seem to like making the quad puzzles. I think you've made several for this series, but they're always very interesting. So yeah, nice use of the quads there. Really nice use of the double numbers, and then also that this hidden 1-6 here like got us off to the races because neither of these wanted a 1-6, so it used up the one spot that could be the free digit. That's neat. All right, cool. Well, I hope you enjoyed this as well. If you did, then why not leave a like, subscribe, and a kind comment below.